All right, so what we're going to do this week is we are going to talk about our case statements. We're going to do some conditional logic. We're going to do case statements. Are kind of the biggest thing there. And you've probably seen me use them before, but they're actually really, really handy. So that's kind of what we're going to be using, which will be really nice. To kind of learn, because they're really handy. There's lots of things you can do with them. So we'll just get started with a couple real quick kind of test scenarios. So it'll be super easy. So let's take a look inside of our customer table. I need to use Sakila. All right. So let's take a look here. Got some address information. We've got this little active flag. So a real simple scenario where case statements really come in handy is for changing output to be more user friendly for whatever purpose it is. So for a really basic scenario, let's say that we want to output some of our customer information, such as our first name, our last name, and then let's get their email, and then we want their active. So if we just do active, we get our ones and zeros. But let's say we want that to be user friendly. Like let's say we're going to graph this, we're going to bin these up and we want it on a graph. Well, we probably want to make it so it's a little bit cleaner. So what we can do is we can use what's called a case statement. And a case statement is just logic that will return different values based on some logic. Now, remember, we're in a column, so it can only return one value in this case. So we're going to say case, and then there's a couple different options we can do. So the first one that has some limitations is we can put case active, and then we can say when one, then yes, when two, then no. And then we can put an else to cover our bases and say unknown. We shouldn't have any of those, but just in case. And then we'll say end as, I'm going to call this active flag. So basically what we're doing is we're saying, hey, based on active, if active is 1, then we're going to put a yes for that row. If active is 2, and instead of a 2, we don't want a 2, we want a 0. When active is 0, then it will say no. If it's not a 1 or a 0, it will be unknown. So let's go ahead and run this, and we should get our little active flag here that is now transformed. And I like that word transformed because it might be on some quizzes. We transformed the data. We took it from what is raw, the 1 and the 0, and we've transformed it and we mapped it to another set of variables. In this case, yes and no. Now, some of the I've already seen this in some of the exercises. There's an exercise where we have to we have to determine if a customer is active or not based on when they last made an order or a rental. So I thought we could walk through one of those together real quick. Let me get logged in here and we can punch that in. While I'm getting logged in, does this case statement make sense to everybody? Perfect. And while I'm getting that loaded up, I need to show you the other way. So in this case, we did our case statement where we put the variable up here. And that's great, but sometimes it has limitations. So for example, if I were to say when between 1 and or 0 and 1, or let's just say in. So let's say we were wanting to check to see if it's valid. Right. It's like we just want to say, okay, do they have a valid entry there? So if I were to run this, you'll notice that I get an error. And that's because if you want to use like any, this works. It saves some typing because you'll see why. And it works if you're just doing when, like basically equals, because the when is essentially equals. When active is equal to 1, then yes. When active is equal to 0, then no. If we do anything besides an equals operator, we have to do it a little differently. So in this case, what we're going to do is we're actually going to just say case, and we're going to say when active in 0, then valid. So we're just going to make one little change and it'll work. So a lot of people actually will just skip this format just because there's sometimes you might have to do some various things. So like, for example, let's say that they're only valid if they're active and email is not null. So it doesn't have to just be on a single column. We can add any conditional logic to this to produce our outputs. So those are kind of the two different ways to see that. So let's take a look at this week's quiz, week 10. Let's do one of these together. Week 10 exercise. All right. All right, so here we have our weekly exercise. On question 4 says write a query that returns the alphabetized first letter of the customer's last name and the count of active and inactive customers. Do not limit the results to only those first letters that occur in the last name column of the customer table, but return the results that include any missing letters from the data set. And then it says, hint, you will need to fabricate a table composed of 26 letters of the alphabet and use an outer join to solve this problem. So basically, the first thing we need to come up with is a table of all of the letters in the alphabet. So let's start off with that. So let's fabricate a table of the alphabet. So I'm going to select, let's see, I'm feeling like there might be a shortcut to this, but because to fabricate, we might just have to go one by one. Let's see, let's go, because the fast way to do this, or the normal way to do this, is to go something like this. And in fact, let's trying to think if there's an easier way to go about that. If there's a way to say, okay, and I think we're gonna have to do it. So let's just buckle down and do it. Grab you. If any of you guys have come across an easier way to do this, let me know. I feel like there's probably a cheat you could do to kind of make this easier. Just before I get too crazy, just want to make sure I'm not messing something up here. Need to get my daughter in here to do this for me. Let's see, and I'm actually gonna make this. Yeah, we'll just keep doing it. L M N O E. You know what's funny? We could just let's do this. I know we're towards the end now, but just so you guys don't have to do the same thing, I'm going to show you a shortcut. So if you have a text editor that can do find replace, I'm going to create a new file. I'm just going to go A, B, D, E, F, G, H, I, J, K, L, M, N, O, P, U, R, S, T, U, V, W, X, Y, and Z. Okay. So if we have a text editor, we can do a little cheating, because what we're going to do is we're going to take every space, which I'm going to put one at the beginning here. We're going to find spaces, and we're going to replace it with select let's see, so select that. Let's do that. Oh, yes. And now what we're going to do is we're going to find select without the space, and we are going to replace that with quote union select. Fix our front one, fix our back, and I think we should be good. There we go. Before I delete all our hard work there, I'm going to just make sure this works. And there it is. So now what I'm going to do, since again, I am lazy and I like to save keystrokes as whenever I can, I'm going to say create table alphabet as. So create table alphabet as, and then we have our query. And now we have an alphabet table. So now instead of doing all that, I can just say select everything from alphabet. And you know what I forgot to do is I forgot to rename the column. It's just called A. So alter table alphabet. And let's rename the column. So we're going to say alter table alphabet, rename column, oops, rename column A to letter. There we go. Now let's select everything from alphabet. And now we should have a letter. So that was a little bit of a workaround, but you get the idea. So now we have, let's make sure we have 26 letters. Yes, we do. That would be embarrassing if I missed one. Great. Okay. So now that we have our data for our alphabet, let's take a look back at our exercise. And so we have the alphabet. So we want all of the letters of the alphabet, and we want the count of active and inactive customers. So the first thing I'm going to do is I'm going to I'm going to get a count of just everybody, just to keep it simple. Because I kind of like to do this. I like to kind of build up. So that way, instead of having to troubleshoot like a whole problem, I can troubleshoot it one kind of layer at a time. So the first thing I'm going to do is I'm going to select a dot letter as, it looks like they call it starts with. And then we want the count of customer ID. So I'm going to get C dot customer ID as customer count from alphabet A. And then when it talks about an outer join, now I know we've talked about this a little bit too, but don't be confused by an outer join versus a left or right join. So an outer join and a left join are the same thing. So in this case, what we really want is we want all of our alphabet, regardless of whether or not there is a customer that has a last name that starts with that letter. So if we take a look at our SQL join chart that I so frequently refer to, these are our outer joins, and which is what we want. Sorry, these are our outer joins because we're getting everything from here. So these are our outer joins, and A is our alphabet. So in this case, we want all the letters of the alphabet, even if customer doesn't have a match there. So let's actually start with an interjoin so we can kind of check this out. So let's interjoin customer C on, and then this is where we have to get the first letter of our alphabet. So A dot letter is equal to C dot, we need the substring, and we want C dot last name and 1 to get the first letter. And just to check, this is another thing that I like to do. If you ever want to know like how a function's going to react, like I said, take it out of the equation so you're not like worried about other things. So I'll say let's get the last name and then the substring C dot last name 1 customer. Let's just make sure. Let's see. Oh, C dot last name. Let's make sure we write our query right. Okay, so then this way I can Q&A my data, right? So here's A, make sure that it looks right, which it does. So that will work perfect. There's our first name, letter. So if we do this and run this, we should we need our group by. Group by A dot letter. There we go. So now we have our results and we can see our numbers here. Now we did an interjoin, so we only have 23 records. So this is what they talk about when they say, oh, you need to use an outer join, because we have some letters of the alphabet like Z. No one's last name starts with a Z. I can see that from right here. And so it's being excluded. It's not being returned from in the result set. So when it talks about using an outer join, because we want to see all the letters regardless of whether they have a match, we can just change that to a left join. left join, outer join, same thing. So now we should see all 26 letters of the alphabet, and you can see Z has 0, U has 0, and that's it. Oh, and X. So U, X, and U. Z, X, and U all do not have people. So there's our count. So now what we want to do is we want to get the count of people who are active or not. And let's take a look back here at our exercise to see what kind of criteria we need. So active count is the second column, and the count of active customers as defined in textbook examples of chapter 11. So let's see, I have my book handy right here on the shelf. Let me grab it. Or you guys won't be able to see this, but I'll read it to you. Chapter 11. Chapter 11 exercises. Okay, so it says, as defined in the textbook examples of chapter 11. Does anyone know what those are off the top of their head? Because I'm looking through the exercises. And they're not there. So it's got to be somewhere else. Active.
Are they talking about page 201, where they define what's active and what's inactive?
Yes. Perfect. Thank you.
And on
Okay.
to page 202.
Yeah, thank you. All right. For example, when querying customer information, you might want to include the customer.active column, which stores a 1 to indicate active and 0 to indicate inactive. Generate important, translate, blah, blah, blah. Fortunately, okay, so it looks like we can just use that column. I'm going to be 100% okay with that. Yes, let's just do that. Because I know that there was a question in the teams and I couldn't get to it yet, but I knew that we would be going over it. So I'll also answer it on Teams, but someone asked, oh, everyone's inactive according to the logic of, oh, they haven't had a rental. Well, we're not going to worry about that because we have a active flag in customer already that's, fits with the fake data. So we're just going to use that. So let's add that in here. So what we're going to do is we are going to write our case statement. So just like we did up here, where we have our case and we have our active flag, yes and no, right? We're going to do the same thing, but in this case, we want a count, right? We want to count things. So there's a little trick we can do that'll be kind of fun. So let's say count. And we're going to say, so we're going to get the count. And I'm going to put us a little room here to breathe. And I'm going to say case when C.active is equal to a 1, then C.customer ID. And we're just going to do it nice and simple. Just like that. So basically what we're doing here is we're counting, right? Same like any other count. We're going to count values. And in this case, what we're doing is we're using our case statement to kind of be a little trick for us. So it's going to go through every record. And when C.active is equal to 1, then it returns customer ID. Otherwise, it's going to return a null. So actually, let's just run this up here. So we have our case here. Let's end as our active flag. And let's just say, let's just paste this here, end as active. So if we run our same, Where am I goofing up here? Oh, there we go. All right, so if we look here, if the customer is active, it's just returning their customer ID. And then we're going to count those just like we would. But if we look at this person who's inactive, it's a null, which it won't count. If you remember back when we talked about aggregations, and many of you in your papers wrote about how null handling in aggregate functions. In this case, it's not going to count that null. So by doing this, we essentially get a count of our active people. Does that make sense to everybody? How what we're doing there, or do we want, or do we need to take a closer look? Okay, perfect. Yeah, this is kind of a little trick that's really nice because it saves you having to write a bunch of subqueries and stuff that otherwise you'd have to do. So this is nice because the case statement inside of our logic here can handle it. So when case.active is equal to 0, then let's just say does not equal 1, right? Does not equal 1, then c.customer ID. And we're going to name this column inactive count. And there we go. And the nice thing, why in their example, they don't have a total count, but I added a total count because I like to be able to see, to make sure that everything adds out. Everything should tie out. So our total count should be the sum of our active and inactive. So 19 plus 1 is 20, 49 plus 3, 52, 11 plus 2, 13. Yeah, so you get the picture. So it looks like we tie out all the way through. So in this case, we have exactly what we want. It's all there. Now, for bonus points, let's say that we wanted to get a percentage. Like we want, okay, here's how many are active. What percentage of the letter of their alphabet is it? Which sounds complicated, but it's not too much because we have all the variables here, right? So if we want the percentage of active, we just take the active count and divide it by the customer count. So if we want to add another column, let's just add another column right here. This is going to be our percentage. We can just take this and that's going to be our denominator. And then we're going to take our nominator and put it there. And we're going to say as percent active. And there we go. And just to make this a little cleaner, I'm going to take and I'm going to multiply this by 100. So we get it in percentages. We can do the same thing down here, just with the different denominator or the different variable on top. So let's just do that. So we flesh this out. All we have to do here is add an exclamation mark and change our column name. Uh-oh, what did I do? I put too many commas. And there we go. So now we have a nice little useful report for somebody that will be useful. Oh, but let's look. We have a couple nulls. And the reason we have nulls is because there's no data there. So at this point, you could either choose to say, hey, there's no data, so we didn't perform that calculation. If you wanted to make it clean, we could also use our function to say if null, wrap this whole thing in here. We're going to say 0. 0.00. Let's see if that fixes our percent inactive column. Let's see. There it is. So let's just make that same change up here on our percent active, if null. So if it's null, we're just going to put a 0 there. So it looks sense. So our bosses don't get mad at us because they don't know what's going on. All right, so there's that one. Everybody clear as mud there? Okay. Anyone confused by this? Okay, yeah, because we did a little bit there, especially with the percentage, so it looks confusing. So just to make this clear, I'm actually going to copy this, and we'll clean this up just a little bit so it makes sense. So let's get rid of our percentages so we don't have to worry about that. There we go. So now we're just back to basically what is asked of us by the exercise. So we have our alphabet and we want all of them. So we select everything from alphabet or the letter. And then we're going to join to customer. So we use a left join because we want to retain all of our alphabet, even if there isn't a customer that matches to it. You know, so like an example, we don't have any customers whose last name starts with Z. So we don't want to exclude them. So we use a left join. So we get everything from alphabet. So I like to remember this because everything to the left of this. And if it helps, put these on the same line. So, okay, I'm doing a left join. I'm getting everything from the left side. So alphabet. And we're joining it to customer C. Okay, so there's our left join explained. So we get everything from the left. And then what we do is, like I said, the first one is just a count of customer ID. And I kind of like the way this question flows because it kind of builds. So the first one is just a count of customer ID. So everybody, we have 20 customers who start with the letter, last name starts with the letter A. So there's 20. This follows the exact same logic. The only thing is we're only giving the count function something to count if c.active is equal to 1. And just to kind of make this, to show you how there's multiple ways to skin this cat, I'm going to change this up just a little bit because we're doing a count where I'm returning customer ID. But let's say that we thought of it just a little bit differently. If we did sum with customer ID, it's going to be a problem. But we can make it simple and just say, hey, if c.active is 1, then return a 1, and we're going to sum that up, which is essentially a count. So if I run this, we'll actually get the same result because each row in our database is unique. So we're getting in our customer table is unique. So we're getting basically a sum we're adding. So if we were to look at this raw, we would have, let's come up here to where we do this. Instead of returning customer ID, I'm going to run this. And now we can see all of our customers. And if they're active, then we just return a 1. Otherwise, it's just a 0. So if we were to take and add all these ones up and organize it by the letter of their last name, we would get the same result that we have down here. Just like that. So it depends on how you want to do it. I personally think the count makes more sense. Technically, if we wanted to, we could just say count c.active in this case, but I'll show you why. If you ever have a table that's not unique and you want like a distinct count, you can always add the distinct flag there. In this case, it's the exact same thing, but that's why I like to return the customer ID and do a count just in case you ever want to do that. Does that help make sense at all? Okay, yeah. If you get confused again, just let me know. Because really, like, most of the time we want our case statements to be exhaustive, but in this case, we're kind of using our case statement as a hack to filter for us. So in this case, we're aggregating. So we only want to count the active customers. So just like we counted the customer ID here, basically what we're doing is this: we're selecting the count of customer ID customer where active is equal to 1. This is essentially what we're doing, um, but we're splitting it up by the letter of their alphabet. But we're only getting the active ones. So this is kind of like our where. So it's kind of handy because instead of having to write a subquery, we can use this case statement to essentially do the filtering for us inside, because and that magic works because we're using an aggregate function, because the count function will only count non-null values. And so by using this case statement, it's like we're making a fake column on the end of every data set that it can count, and that data will only be there for people who have an active flag equals 1. All right, let's move along to the second one. Question 5. We're going to write a query that returns the alphabetized first letter of the customer's last name and the count of active and inactive customers for only those letters where the count of active customers is greater than 30. The count of active customers is greater than 30. So I'm going to take our same query here, and we are going to put it here so we can keep them. And we want only people who have an active count higher than 30. So like if we take a look at our original data, an active count higher than 30. So we'd get B, C, G, H, M, R, S, and W. So, we want to kind of filter this out, but and I think we've covered this before, but we want to exclude, and I was looking at the customer count, which is probably the same. But we want to exclude on an aggregation. So the way we do that is with the having clause, which is at the end. So we're going to say having, and in this case, we can kind of build our filter. And in this case, we're going to use our same thing. So what's really nice is we don't even have to reinvent the wheel here. We can just take and we can say, hey, if they have a count that's greater than 30, greater than or equal, did they say greater than 30 or greater than equal to? Greater than. So we're going to say greater than 30. It will return it. So let's go ahead and run this. And boom, there we go. So that is a prime example of something that sounds really complicated, but we've already done the work, so we can just take and copy it or reuse it. So just to explain this again, we took our same query that we had before that did all the things, the great things we talked about. And what we wanted to do is we just wanted to filter our result set so that we only had we only wanted the records that had an active count that's greater than 30. And we have the active count already pre-built, like we discussed. We already have this column defined. So we're going to just take the same way we calculated that and put it in the having clause. And the having clause is different than a where clause, because the where clause would run before the aggregation, where the having clause runs after. So we have to use the having clause because we're filtering on aggregated columns. So because we want the count that's greater than 30, we have to use the having clause instead of the where clause. You'll notice that I don't have a where clause. So we say having a count, and we use the same logic. So only count the active customers. And if they have a count that's greater than 30, they're included. So we run it and boom, there we go. And it should match exactly what we have here, which it looks like we does. I just have that extra column, which I don't know why they didn't include, because it just makes sense. All right, does that make sense to everybody? Cool. Cool. Yeah, those are fun exercises, and you guys get I guess everyone who watches the video will catch a little break, because you've already been through it before and you'll know exactly where to find it. So I would recommend, don't just type this out when you get it. Like don't pull up the video, type it out. Obviously there's nothing I'm going to do to be able to stop you from that. But what I would recommend is try it from scratch, because you'll always have those rails to come back to. But to help you truly understand it, see, now that you kind of have like the logic kind of planned out, like you can see the general diagram in your head, so to speak, because you've seen it. Try to do it yourself to make sure you understand case statements. And if you get stuck, then go check out the video. But yeah, that's what I would recommend, because that's the best way to learn. This is actually a really good example, because it builds. And like I said, there's fun things you can do with it, like I did, where like let's add the percentages, because a lot of times that's what people want to see. All right, so those are case statements in a nutshell. Lots of different things you can do with it. This example is more of kind of like the way you can cheat using a case statement, but also very handy. Very handy. Because like we showed in the above example, where we just changed like a yes to a no. That's kind of more like the traditional way, the plain way to use case statements. But this is actually where they come in really handy, is for stuff like this. But you can use them all the time for various things, like when you're mapping, translating. So just to kind of throw some terms out there, translating is when we turn one value into another, we map it. Like a translation, if you're translating and you say C, you correlate that to yes. If we're going from Spanish to English, we map C to yes. Same thing with this. We mapped a 1 to a yes and a 0 to a no. So that's why, translated. The other word that you might see with it is transformed. We transformed the data. The raw data was transformed. We took the raw data and we changed the output in some way, shape, or form. And in this case, we did an aggregation. So we not only did we transform the yes, no in the previous example, but in this case, we transformed the data because we took many records and we turned them into fewer records with our aggregation. So we transformed the data. All right, but that's all I have. If you guys have any questions about final project, we're about out of time, but if you have any questions about final project, I'm going to stick around for just a little bit longer if you need to pop something off me, but otherwise feel free to jump off and have a great week.